Hi everyone, Kevin Dart from the Fastener Lab, and in this video I just want to start going over how to generate your toolpaths and working with RhinoCam. So in our last video I laid everything out, and between now and then I deleted any extra things, and another thing I did was I moved all of my lines and stuff over to a new layer, and here I can see that I've also took specific parts of this drawing and put them in sub layers. So I've got my dog bones, which are right here. Oops, saving. I've got my interior curves, which are right here. Now these are a little separate from the dog bones because they're bigger, and I really want to distinguish between sizes of things when I'm doing this layout and setting some things up. So you can see I've got these interior curves, which are much bigger than the dog bones, and I've also got these holes, which are separate. Little holes here, and then our exterior curves. And the reason I'm doing that is when we're doing our machine operations, when we're actually cutting, we actually have to have tabs to hold these in place, so that when it's cutting, they don't fly away. And in the machine operations, I'll show you that. So this is the PC version of Rhino. We have to use the PC version with RhinoCam, and you can only use this in the DigiFab lab in the Fastener lab. So I recommend just saving your file to the network drive or thumb drive. Network drive is much easier. But let's just get started with the RhinoCam. So if RhinoCam doesn't automatically pop up, you can come up here to RhinoCam 2016, and we're going to go to Mill. You want to make sure you're in Mill, and this will come up. And right here is the Mill, but we're just going to go into Program. Oh, turn it to the lathe, but we want to make sure that this says Mill. And this is our tool library, which you probably don't have that, but I recommend once you make your tool to save it here. I'm going to hit close. And so the first thing I'm going to do is I'm going to come over here to Machine Axes and double click this guy. And I want to make sure that it's just in 3 axes. This stuff, this can stay where it is. It's not a huge deal right now. Manual definition, 3 axes, and hit OK. Now another thing is I want to change my postscript, so I'm going to double click post. And now if you're not in the digifab file, you want to find this. So you're going to come over here, click this button, and see, you're going to be in this folder, and it should be right on the desktop, so you can just hit digifab, hit OK, and you can come down and you can see like there's the Torchmate file or post processor for the plasma, but we want ShopBot, so we want to make sure we're in ShopBot, and then you want to make sure that your file is the .nc. All right, and you can hit OK. And then the next thing is we're going to come over here and make our stock. Now the stock is essentially our material, right? So if we're cutting sheet of plywood, this is going to be the same thing as our sheet of plywood. And again, that's why I made this separate material layer, and I made it, starting at the origin, so it makes everything nice and simple and easy. If I go to my perspective view, here we go, you can see that there's my box, and I'm going to double click this guy, and what I want to do is just hit copy model bounding box. Now when I do that, it automatically will copy whatever the size of all of your objects at once. And so all of my objects, all of my lines and things are within this box. So that's why it's saying 96 by 48. And it's giving me this really weird height, which is a super small number. Same thing up here. Now what I want to do is I want to, let's see here, we can do this guy. Let's see if this works. Well, 0 and right? So what that did was it made this, so I'm going to come back here to stock, and I'm going to show you, is that what it did was it made our corner coordinate system 0, 0, 0, which is what we want, and then I clicked on this point up here, which is the top left corner, which is the equivalent of this corner right here, and I made the height 0.5. So that's where essentially our stock coordinate system is starting at, right here. All right. So that's what you want. That's what you're looking at. And the reason I want that is if I'm looking at this from a side view. And I can see that that stock goes below, somewhat in the negative direction of our Rhino coordinate system. And again, the reason I want that is because I want that geometry to be at the top. And if I think about this in terms of the router is going to 0, or kind of set where its coordinate system is to the top corner here as well. And that's why I have it below. All right. So the next thing I can do is come over here to setup, and really don't need to do much here. We can just hit OK. We just want to make sure that everything looks fine and dandy, nothing weird. And that's because, again, I'm just kind of locking it to the coordinate system that already exists. All right. So the next thing I can do, I'm going to delete this to show you, is I can come over here to Machine Operations and start a Work 0. Now, a Work 0 is essentially kind of like a mobile construction plane in terms of writing toolpaths. So you can kind of say, I want my 0 to be here, or I want my 0 to be at this point. The reason you would do that is because you might have multiple cutting operations that will require that 0 to change based on, like, if you cut some material away, that might change your new 0 or your Work 0. So I'm going to just click Work 0, and this is pretty straightforward. I'm just going to go in perspective view to show you, is that I'm going to set it to stock box. Now it automatically picks this corner up here, this northwest corner. I do want it to be at the highest Z because, again, I want it to be at the top of the plane here. And you can kind of play around and you can see where this goes. Now I want it to be the southwest corner. And again, that's because that's where our CNC router goes to its home or its coordinate system. And I can hit generate. So set to stock box, highest Z, southwest corner, generate. And there we go. And so we've got our Work 0 and everything. I'm going to go to the top view. And if you care enough, you can change the color of the material. Sometimes it automatically comes up as aluminum, so it's this weird gray against gray. I like wood, so it's a little bit of contrast to show you where your stock is. All right. So now what I can do is I can start my machine operations. And the first thing I want to do is I kind of want to go in this order from small things to larger things, or really I want to end with exterior curves. The reason I end with exterior curves is because these are larger things, and when they're cut out, they might shift, they might move, depends if the wood is warped or whatever the material is. And I want to cut it out last to make sure that everything in here is precise. If I cut the exterior curves first and something moves or something gets knocked out, when it cuts these interior curves, it might be a little off. So in general, cut it interior curves first, exterior curves last. For now, I'm just going to hide everything, except for my dog bones, which will be the first thing I'll cut. I'm going to come over here to Machine Operations. I'm going to do 2 axes, because we're not doing any sort of 3-dimensional cutting, and I've got all these options. Graving, pocketings if you want to cut out large swaths of area. But I'm going to do profiling because that's just essentially cutting an outline of a shape. So I'm going to click profiling. And then the first thing it's going to ask me is select your control geometry. And these are just going to be my curves and whatnot. So I'm going to say select curve edge region. I'm just going to select all of them. There we go. And we can see that kind of like already generated a toolpath, but we can edit that. And the first thing I'm going to do is I'm going to come over here to Tool. Now I've got all of these nice tools in here. And let's see, where is my 1/4 inch end mill? 1/4 inch ball. Ooh, maybe I don't have it. All right, we can make a new one. So you won't have this, but what you can do is come to Edit, Create New Tool. Edit, Create New Tool. And you get this window that comes up here, and you've got different options to start with: ball, edge, flat, corner, all these random things specific for different cutting jobs. You want to start with a flat mill. Now change your name. I'm going to change my name to foam. Actually, I'm going to change it to wood, 1/4 inch upcut. Now there are different kinds of bits. There's upcut, there's straight flute, there's downcut. But in general, you want to label it something that you know what it is. And I like to put the material in there because the material dictates its feeds and speeds and things like that. So what I'm going to do is the holder diameter is 1.5, holder length 1.5, shank diameter is 0.25. Now that is, shank diameter might change based on the diameter of your tool. These numbers all came from the tool itself, or the bit that you purchase. So when you put this in, you're going to have to find or measure these yourself, and this diagram shows you what you need to measure. I think actually shank diameter is 0.5. That's about right. Yeah, it's 0.25. That's right. And my tool length is actually measuring it right now. It's 1.5. The total tool length. So it's actually about that big. All right. So once you get all these in, you can save as new tool. Save as new tool. The tool number, just hit OK. And then we've got it. But what our next step is we need to come up here to Feeds and Speeds. And I'm going to say Load from File. All right. And now we can type in some things here. Now, feeds and speeds are very important because that dictates the rate at which the machine is going to cut your material out. Now, if you go too fast, you can risk breaking your bit or hurting the machine because it's trying to cut too much away at once, and that could be detrimental. If you go too slow, you could kind of burn up the wood. You could have burn marks, things like that. And you might not get a nice clean cut. So there's a happy zone for these things. I'm going to hit cancel right now. I'm just going to hit OK. I'm going to come back to that because I'm going to show you there's a link right here. You can go to the DigiFab Lab tutorials. Pop up. And I'm going to go to Sitemap. And right here, I can find the Feeds and Speeds link, which goes over what feeds and speeds are. So, cutting speed is the rate at which a cutting tooth moves along the material. Feed rate is the rate at which the machine moves. And it goes through an example. And so there's some important things that we want to find here. Really, this is a lot of good information. This whole page is good information. But we can see that our chip load is 0.004. Depending on what your tool is, you might have 1 or 2 flutes, and then it goes through that at there. So when I go back to here, and I go to Edit, Create New Tool, I'm going to pick my wood upcut bit one I just made. Edit, Create New Tool. I'm going to come back to Feeds and Speeds. I'm going to load from File. So I'm going to pick wood, carbide, and I'm going to change my feed tooth rate to the 0.004, which is how much material it can take away at once. 1600 is a good surface speed. Tool diameter is 0.25. I do have 2 flutes. Now the spindle speed, our max spindle speed is 1800, and we might set it for 1200 or whatnot. So I'm going to set it to 1200, and then we get our 96 inches per minute cut feed rate, which if I look back here, now they have it at 1800, which gives them 0.08, but this is generally a good number with a 1/4 inch upcut bit. So I'm going to hit OK. I'm going to say Save Edits to Tool. Hit OK, hit OK. So now the tool is done. Now if I come over here to Feeds and Speeds, I'm just going to hit Load from Tool, and it's going to automatically enter all of these things, which dictates, how fast it moves up, down, over, cutting into things, whatnot. Next, I'm going to go to Clearance Plane, which is how high it safely moves. And we can hit automatic, or what we can do is we can go to stock max Z plus distance. And I like to do that. I'm going to say stock max Z plus distance. I'm going to say 0.75. The reason I do that is because some pieces of plywood might be pretty warpy, and they might actually pop up a 1/4 inch. I think the standard, the automatic, is 1/4 inch. And if it pops up, if your tool is moving along, it might actually cut into your wood. So that's why I go 0.75. And it's worth a little extra safety. The next thing I'm going to do is I'm just going to move up here to sorting. Seeing as how we're there. I'm going to go minimum distance sort lower left. And that's because it's going to start where the origin is, and it's going to kind of create the best route, fastest route to cut everything out. Next, I'm going to go to advanced cut parameters. I'm not going to worry about rounding. If I'm going to do arc fitting, I'm going to add an extra 0 there, just so we're nice and precise about it. Now down here, the bridges tabs, these are what hold the pieces together. And this might change based on the size of these things. I like triangle cuts, and I usually like to do it, the height of it as half of the material and the length as twice, or the thickness of the material. And for these little guys, 2 is fine. Sometimes, depending on the size of it, the router bit might actually just cut everything away. Entry and exit. I'm going to say none for exit. And for entry, I'm just going to say a long path. And it automatically kind of figures all that out. Now, our cut parameters and cut levels, this is where this dictates kind of how thick we're going to go. So I'm going to say at top. That's the location of my geometry. Remember how I said I want everything on the top surface. Our total cut depth, I'm going to say 0.45. Or no, I'm going to say 0.46. Just make it an even number. And we're going to do a complete, everything's going to be rough. We don't need to worry about finish cut. The reason I'm doing 0.46 is because I don't want to go all the way to the bottom. I don't want to cut into the table. I want to leave just a sliver of wood that can just easily be, cut out with a razor blade or anything like that. Rough cut depth. This determines how many, essentially, depths we're going to do, or how many passes, so to say. And that's half of what you're doing. All right. And so that's what I'm looking for right there. And then when I come over here to cut parameters, you can leave all this where it is, but right down here I'm going to say use outside inside for closed curves, because these are inside. And I'm going to hit inside, and I'm going to hit generate, because everything should be good. I'm going to hit generate. It's computing the tool paths, And there we go. I can see. Now if I look at this in perspective view and zoom in, I can see that it's doing one path, and then it's going to come down and do one path, and that little triangle right there is the bridge. Now I am actually going to come back here, and I'm actually not going to do bridges with dog bones because it's practically the width of the dog bone is the thickness of our material, so I'm just actually going to hit none, but the other ones I will put in dog bones. It just makes my life easier later, and that's what I'm looking for. So that is basically how to set up things for your first operation. And in the next video, I'm going to show you how to do these other operations and the whole operation. So I hope you enjoyed it, and I'll see you next time.